So it turns out that just as with a t-test, most of the things that we're going to do with regression are very robust to normality. So any kind of p-value you might calculate, or any sort of interval you might, well, you can be careful. Any confidence interval you might find are, and also your predictions themselves are robust to normality assumptions. Okay. I'll put in parentheses here, there's an exception coming. There's one thing that we're going to do to draw, one conclusion we're going to draw from a regression that is not robust to the normality assumption. So I'm trying to write the word exception. I'm having trouble for some reason. Exception coming. Okay, so there will be an exception. But in general, just like with t-tests, we feel pretty comfortable about the normality assumption. In other words, we're not that worried about it. The last assumption that we're going to talk about is equal variance. So note that what we've listed for the regression assumptions was first linearity. In other words, the model equation has to be true, and then the same three assumptions we had for the pooled t-test. Now, one question I talked to a few of you about when we were discussing t-tests is, why do we have to learn the pooled t-test when we can always just use the unpooled t-test? Like, why bother worrying about whether the variances are equal in a comparison of two groups when we have this method available that works really well, that doesn't require us to assume the variances are the same? And the reason is that as soon as we extend the analysis to not just two groups, but three or more groups, which is what we're doing here, then the conventional methods do assume equal variance. In other words, regression is a generalization of a pooled t-test, not the Welsh t-test. So what has to have equal variance? Well, actually, it's the same kind of thing we said about normality. The assumption is equal variance of y values within each subgroup based on the predictors, based on X. So what you want to have, here's X, here's Y, here's my 1, 2, 3, 4, 5. If the assumption holds, it should look something like this. The amount by which the Y values vary within each group based on X should be the same. So this assumption is met here versus here's an X, here's a Y, 2, 3. One common way this is not met is, for example, maybe for smaller values, the normal distribution of the Y values is a little closer together, but as X increases, the variance of the Y's increases as well. This assumption is not met in this case. Now, there's things you can do. Shockingly, the thing is going to be to take the log, but this is one of the assumptions underlying a regression. Now, are there things you can do if this assumption is not true? Sure, I just said you could take the log. There also are some other methods out there. There's one called robust regression, but those are not nearly as conventional as something like a unpooled t-test. Certainly, people do them all the time, or frequently. Not all the time, frequently. However, when you're running t-tests, it's actually the default when you run a t-test to assume the variances are not the same. But when you do a regression, the very strong default is to assume the variances are the same unless you're convinced otherwise. And there's no particular, knowledge about the world that I have that tells me that when you have two groups, their variances might be different. But if you have three groups, their variances are probably the same. That's not the case. It's just that the math is a lot harder in a regression if you don't assume equal variance. And so for that reason, we need to be worried about this assumption. The equal variance assumption has a couple other names. You'll see it called constant variance. And then one of my favorite words in statistics, this is also called homoscedasticity. Homoscedasticity. Okay, that's my attempt at neat handwriting. If you don't have equal variance, that's called heteroscedasticity. And also, just so you know, in Britain, they spell this with a C instead of a K right there. So it's not a typo if you see that spelled with a C. Or maybe it is a typo, but it's a lucky one that happens to also be correct. We said that linearity is crucial. We said that independence is really important. We said normality is not that important most of the time for regression. Equal variance is important. It's required for things like p-values and intervals to be correct. when you're running a regression. So more than in the t-test case, we do need to be making sure our assumptions are met as we go through a linear regression.